Hey, Wages World, what is cracking? What's going on, Kool-aid Krew? We got some stuff to talk about today. Yeah, so give me a 5 for 5 and we'll get rolling right on through if you know what I'm screaming. But yeah, so let me go ahead and transfer over to the what we wanted to be talking about today. Guys, we got some, we got some pretty decent sized solar storms headed this way. It is most likely going to be at least a G3. I'm thinking probably maybe even more. Last few times, guys, we've underestimated some of these solar storms, so I don't want to do that again. And so we're going to try not to do that. So, all right, guys. So what you're looking at there, that would be a model of our inner solar system. It's called the Enlil spiral. And what that does is basically it's tracking CMEs. So that's what we're going to look at, coronal mass ejection. That I actually had a question what a CME was yesterday. I wasn't able to answer it. So a coronal mass ejection is nothing more than plasma erupting off of the sun. Okay? It's an eruption. It's in the corona of the sun. It's mass, which means it has its particles. Okay? It's not light. And it's a charged gas. Solid, liquid. Yeah. Solid, liquid, gas, and solid, liquid, gas, and then the fourth state of matter is plasma. What is plasma? Plasma is a charged gas, nothing else. You know, like when you go to Taco Bell and you eat too much, you kind of get charged, right? No, I'm just kidding. Just a little bit of a joke there. All right, guys. So, thank you, Planet Hermit. Appreciate you again, man. You guys are killing it. Love it. Love it. Love it. Also, so let me show you this first because I don't want to, not show you what we're going to be talking about here. This model here shows us 2 days historic data. But it tries to forecast 5 days out in advance. Now, I don't trust it 5 days out. Most people don't. It's not very accurate. It just gives us kind of a ballpark figure. So what this is but they will change it if the data changes. So that's a good thing. So as conditions change, as they start getting more data in, they will adjust this model. And they should. So basically from right about here is where we're at now. This is exactly what happened. Okay? But 2 days ahead, 3 days ahead, that's what we're talking about now, and that's what they're forecasting. Obviously, we can't read the future. So, with that being said, we are going to take what looks like to be a double or a triple hit. And I'll be able to show you guys that here in about 2 seconds. You can see right here, now on the top here, this is density. Right? The bottom is velocity. So as I move forward here, you see how that kind of separated right there? Those are two separate CMEs. They just fired off real close to one another. Okay? They both look to be traveling about the same speed, which we oftentimes talk about the snowplow effect and what we call a cannibal CME. A cannibal CME is a CME in the front that has been fired off from the sun, and then one behind it is moving faster and catches up to it. Now, they never truly eat one another or combine. They don't do that. They get real close to doing that, but what happens is the particles that are in between them get a snowplow effect, and it builds up in between them and becomes a very dense shockwave, usually. So that in itself acts as if it might be another CME. So with that being said, yeah, that is a pretty brief explanation, I guess. I don't really want to go too much more into details about the technicalities of all that. But as you can see, this looks to be like a 15 on the density. 4 is what we would consider normal. But I've seen, and I've said this a bunch of times, we'll get a density hit of 30 and not get a geomagnetic storm at all. So it's more than one data point that causes geomagnetic storming. Okay? This is the velocity down here. Now, as I'm looking at this, you can almost see 3, right? You guys might, if you're using your phones, you might not be able to see kind of 3 separate little, there's separation there, is what I'm saying. So, and this is a top down on the left side, and this right here is a side cut. So both cuts are showing us different axes, right? Axis. So as this thing fires off, we get to see the side view, which gives us north-south orientation, and then the top-down view will give us east-west. And when we're talking about looking at the sun, east-west is actually reversed. So what we would normally think, like looking at a map, the west would be to our left, right? No, not when looking at the sun. You have to pretend you're standing on the sun. So as this thing hits, boom, right? Now, this is going to be a very, like, initial quick hit. But it's going to hang around, and I'm going to show you that here in a second. But don't be fooled by this, okay? This here, the density here on this graph, it looks as though that's like a massive density hit, right? You always have to consider your indice range here, okay? What we're actually measuring and the numbers that they're using. Typically, when we look at this will say 0 to 10. That's like its default. But when things get more intense than that, they have to raise it. And I showed you guys one, I don't know, a couple weeks ago. The density was all the way up to like 100 or 80 or something like that. And this looked very similar. But this is not that dense as the one a couple weeks ago. So I just want to make sure we understand that. Now the green line here, guys, is the conditions at Earth. Okay? So there's really nothing more than that to, you know, kind of, I don't know, kind of put into that. But, okay, so what I want to do, guys, is I want to show you guys these CMEs. So the first thing I'm going to do is show you SDO. SDO is a satellite from our perspective, okay? That perspective being just from our perspective, right? And I know that kind of sounded weird, but we don't want to think that we're looking from different angles. So we have to really pay attention to this, okay? It's important to know that. Because when I show you, let's do this here real quick. What I'll do, I meant to have that pulled up too. Sorry about that, guys. When I show you this NASA CME tracker, you're going to see this is the Earth here, the yellow ball. This is the sun. That's stereo A. That's another satellite, right? So when I show you guys different satellites, we have to understand where we're looking from. This satellite is not from our perspective. It's off to our, would be our west, because things are reversed. Remember, east-west. Now north-south is the same, but so when we're talking about this, that's why when I show you, what is cracking? What's going on, Kool-aid Krew? Uh-oh, hold on, people. Yeah. Sorry, guys. Rookie mistake again. I kind of lost where I was going there now. So when I show you guys this says stereo A. This is the conditions at that satellite. Okay? That's what I mean when I say that. So this is stereo B. And the conditions at Earth are forecasted to be here. So, yeah. Now, what I want to do now, guys, is take you guys back over here to SDO and let you guys see these things erupting. Nothing more than that. I mean, we're going to see multiple flares. I'm going to speed this up. And it started on the 30th with an M-class flare, if you remember. Okay? I reported on that a couple days ago, and then we got the X flare after that. So you're going to see most of it coming from here. But these other ones are flaring a little bit too. Okay? Like that one there, that was a significant one. That was a significant one. Okay? So you're looking at all of them. Now that right there is a calibration roll. Don't nobody freak out over that. That is nothing to freak out about. Okay? They actually do a calibration roll with the camera or the satellite itself. So it has to find home once in a while. We have to know where its base is, right? So we can steer it and keep it in the right place. So what's that mean? Well, they have to do these calibration rolls. That's what that means. And oftentimes, you know, if you didn't know what you were looking at, that would freak you out, right? And sometimes these satellites, you know, they do move when they get hit with solar winds, space weather. They do move and they will shake like that a little bit. Now, let's go over here Hey, Marilyn, thank you for re-upping that membership. You figured it out. Awesome. Thank you. Thank you, thank you, thank you. And thanks again, Planet Hermit. You kill it, man. I mean, it just wow. I'm so floored with that kind of stuff. So humbled. I really truly am, guys. So thank you for all the support you guys give me. It is so much appreciated. And also, before I move forward with that, I want to clarify. I think I didn't explain myself well enough yesterday with the members only. I was asking if you guys want me to go on after Adam, not last night. It would have been, I might have even said last night, but I didn't mean to. I'm talking moving forward. If there's going to be anybody interested in actually coming after Marfugal TV to do a members only that late. Because I'm trying to figure out 2 different separate times so I can kind of hit everybody. You know, and I guess what I'm going to have to do, I'm just going to have to do it and see how it works. So, but thank you to all you guys that participated in that poll. That poll was on the members only community tab. So if you're not a member, you wouldn't have been able to see it. But I was just asking what time they wanted to do the members only, pretty much. So I'll give you guys the results of that later on. I just don't want to have to go over there right this second. So, guys, we're going to look at the coronagraphs now. Now, the coronagraphs are on a satellite called SOHO, right? And it's right here. So let me, this is the SEEDS website, right? George Mason University Space Weather Lab. That's who runs this website, okay? They get the data, and then they put it here, right? They're not producing the data. They're using the data. So with that being said, what does that tell us? That tells us everybody else can use the data too. And so when somebody says, hey, we're missing data, and they've only looked here, they haven't done their due diligence and went and looked. They need to do that because almost every time you can find that data that you think might be missing. So I'll just say that. Now, I used to think the same thing. I really did. I used to think that, you know, hey, man, we're missing some data. What's going on? Did the satellite have a glitch or did they pull it down for some reason and all those kinds of things? But after digging into this stuff and I was able to find the data that I thought was missing, I just didn't know where to look, right? So anyway, let's look at the actually, I'm going to go to the previous day. We're going to go to the first here. Now, crap. I meant to show you this first. Here's the Earth. Here's the satellite. From our perspective, it's just 1 million miles closer to the sun than what we are. All right? And this is an actual disc on the camera. It's blocking the main light of the sun. It has to be there or the camera just gets flooded with light and we won't get any imaging at all. Okay? This is a difference image, and this is the one I typically will show you because it gives us good contrasting colors and we can see more definition. Over here is just, it's a regular chronograph, and they've chosen to make this red. So that's all that is. That right there is Mercury, okay? It's actually on the backside of the sun. But right here, this is the surface of the sun, this white circle. So when things erupt off, we don't get to see what erupted for about an hour to 2 hours after it erupted on this particular satellite. Now, we get to see it right here immediately, right? Because there is no occulter disk. This is using filters, okay? It's not using an actual, capturing device as far as a shutter opening and closing or baffles doing this to the light back and forth, right? So I'll just say that. Now, this is back on the first, and I went through this a little bit yesterday. Well, actually, I kind of went through it a lot. I'm going to pause it right there. If you look right here, you're going to see a little bit of a shady whatever, right? It's going to look a little bit hazy, I guess I'll say. So if you look at this, you don't see that here. Now, if I go forward, you see how kind of this color right inside my cursor here is different? It's kind of like, I don't know, almost looks like fog, right? It's blurry. So when we see that, that typically means that's space weather. That is plasma. So, yeah. Hey, Stormblade, thank you. Thank you for being a member for 2 months. And thank you for using that free super chat that you guys get. I encourage all you guys, please use that free super chat. Hey, J-Poss, thanks for being here, brother. Okay, now, but thank you again for doing that. Appreciate you, Stormblade. Really do. Thank you guys for all the uplifting messages and stuff, too. You guys are just awesome. So, that's what I'll say. I use that phrase a lot, too. That's what I'll say. Anyway. So, you get this hazy look, and that is space weather. That came from that M flare. Okay? That one came from, well, this flare here. Okay? It's almost off this chart right now. It's time moving forward. And then we got another M flare, and then we got the big X flare, and we've had 3 subsequent longer duration M flares, I have to say. Okay? Now, I'm not sure what happened here, guys. I was looking at this, and it kind of struck me just a little bit weird. I'm not really sure what happened there. It might have been just an error in data collection. But when you see these reverse spikes, this is just, they can't get the data. Okay, there's a data dropout because of the position of the satellite. Okay, that happens. They know it's going to happen, and that's what, we're able to forecast it. Say, hey guys, pay attention to this, right? This means nothing. This is just nothing more than that. But they're typically about 24 hours apart. See how these are? This one, number 1, is only like 12 hours apart, and it did not spike all the way down like these other ones did. So something different happened there. And I don't know what that was. I can't see the sun just quieting the sunspots for a half hour, 45 minutes there. And then, boom, here comes all the X-ray again. Right? Because that's what this is measuring. It's measuring X-ray. So I don't know what happened there. So if anybody's asking, I don't have the answer for that. If anybody knows the answer to that, please tell me. Just saying. Okay, so now as I show you this SOHO imaging, remember, this is the same imaging, just zoomed out. This is LASCO C3. This is a zoomed in version of the LASCO tool that's on that satellite. Okay, now I know I kind of talk fast there a little bit, but what you've got a SOHO satellite out there. They call it an observatory. It's a space observatory. Okay, it's on that satellite, and it has a bunch of different tools on it. It has a bunch of different imagers, data collection equipment, and a whole lot of things. Right. So when I show you this is just the same, coming from that same satellite. So it's from our perspective again, but this is zoomed out. I show you guys this off and on. I don't use this as much as I do this one, because we get a zoomed in version, right? Now, once the CME or whatever happens here leaves the screen, I will come over here and, yeah, where am I at here? Yeah, and show you this one, okay? Now, we always want to pay attention to our timestamps here, okay? So we don't want to be confused. Now, when we're talking about time, when we're using space weather tools, what we're going to be talking about is UTC. That's just the standard measurement of time that the whole world uses in the science community. Okay? We do that for one reason. Because if I was saying, hey, it's 6 o'clock where I'm at, we had a CME at 6 o'clock. Well, you go to a different time zone, it ain't 6 o'clock for them. So it can get very confusing really, really fast unless we use a standardized, hey, we're picking that time zone. And yes, it's Greenwich. It's the old Greenwich time zone. It's in England, okay? So if you're on the East Coast, UTC time is a 4-hour difference, okay? So if it's 12 o'clock UTC, that means it's 8 o'clock Eastern Standard. So you can get time zone stuff if you want to go look at that on the internet, calculators and all that. But if you just remember that, you can figure it out yourself pretty easy. But yeah, so as you can see here, guys, this is showing eruptions too. Now, I'm not sure where that one came from. I haven't looked yet. That's going off the north side, and that seems to be a very, very dense shot, okay? It's bright, and it's, like, compact, okay? Typically, when we see these, you see this hazy look, right? That's what we usually see. And we'll see bright, too, but that's just an excessive amount in the same spot. So that's probably a pretty decent shot there. That is not coming at us. That's definitely going north of Earth, even if it's coming our direction. Remember, that's an occulter disk, so things are going to look the same going straight off the back as they do coming right at us. Okay, because we don't have a side view to look at. All right, and I want to show you guys something here too. You guys see this? And that? And that? Okay, those are probably charged particles flying in front of the camera. Okay, that's how the camera will interpret those sometimes. Other times, those will be bigger, and they'll look like the imager itself. And they'll be all over the screen. It's just a camera anomaly, okay? I was going to show you guys that today, and I'm not because of what we got going on. I wasn't expecting all these CMEs today. But I also want to point this out. That is a massive sunspot. Okay? I mean, that thing is huge. There is just no way around saying it any other way. That is a massive sunspot. And it looks to be like it could be pretty dense. And, you know, now just because it's big in size does not necessarily mean it's going to be powerful. Or it doesn't mean that it's going to be erupting. It has to have all that dynamic at the same time. So with that being said, we're going to dive into that here in just a minute. But what I want to do is, this is going to probably shock some of you guys, so don't be getting all freaky deaky on me here, all right? Don't worry about this, and don't think it's something that we didn't expect to happen. Here's our sunspot numbers. Remember last month we broke records, right? I mean, we're way over anyway the forecasted, but look what happened in September. That's a massive drop in sunspot numbers. Now, before anybody starts thinking that, you know, it is this and it's that and all that, it almost dropped in, I don't want to say in half, but it was, let's see, what would be the exact number there? 215 and 141. So yeah, roughly 75 less sunspots that month facing Earth. Okay, so what that means is this is just following historic data, guys. Okay, that's what we expect it to do. It's not going to go up here and stay up here for, you know, 30 years. So if I take this and I roll this back, you can start to see the pattern, right? You can start seeing, you can almost take this and overlay it, and it's going to look very similar to this. Okay, so with that being said, we can kind of gauge, at least roughly, what's going to happen in the subsequent months moving forward. Now, it's not going to be exact, but it's going to look very close. Okay, because if I go back to the previous, even back to solar cycle 23, see how they all look very, very similar? That's what we expect, guys. Okay, so don't think it's anything weird that this sunspot number dropped out, because it did. It dropped out with in a massive way. I mean, look at this drop out over here, right? This one to here is more impressive to me than this to here. And the reason why is because this is actually a greater percentage from here to here, because the numbers aren't as high. So you didn't lose as much percentage going down from here to here as you did from here to here. Okay? So that's what I'm trying to say. Just keep that in mind. Now, over here, this is Helio Viewer. This is that sunspot. Okay, way over here on the side. This is Earth scale. That's the size of our planet, to scale. Now let me zoom in here. Okay, check that out. 1, 2, 3, 4, 5, 6. I mean, you can see how big that sunspot is. Okay, so I just wanted to point that out because it's significant. Also, you see this little tail? We've been seeing that quite often, and a lot of our sunspots do kind of take that shape. But the Carrington event actually had that similar shape too. So, but it's all over everything. You can go look at other sunspots, and they're going to really closely resemble this shape. It's just what they do. That's the shape that they take. They don't have to, but a lot of times they do. especially when you got a big one out in front. So what you're looking at, these little cores. And with that being said, if I take you over to this is SDO again, but this is a magnetogram and it's colorized, which means that we get to see the polarity. The polarity is the reds and blues, okay? When those things start mixing together, we get reconnection events. In other words, it's like taking two jumper cables and touching them. It flares when that happens, okay? So watch this sunspot. Remember, this is the one that did the M flare and then the X flare yesterday, okay? Now watch what happens. This is the one that did all the flaring, I think, right here. But look at the one trailing behind. You guys see that? This thing just exploded with energy. And when I say exploded, it just got bigger. It didn't like erupt off the sun or anything. At least not to like I kind of put that there. I shouldn't have worded it like that. But as you can see, we got clear, you know, positive, negative, reds and blues separated from each other. But look here. These things are going to start swirling around. And that makes them unstable. Also, this one here, we can't forget this one either. Look what happened right in the middle. That's a opposite polarity right in the middle of those two red spots. Check out this one. You can clearly see it up here. Now, some of you guys might be noticing that on the northern hemisphere of the sun, the polarities are different than what they are in the southern. That's normal. That's the way it's supposed to be. Okay? Let me take a drink here real quick, guys. My mouth's getting dry. Sorry. I'm going to pull my mic away. Okay. So, I'm back. I'm back. Come on. I'm really, really back. Boom, boom. Okay. So, I'm going to play this one. Now, this is on the first. Remember, guys, that's that flare. Now, that one did come at us. That's probably going to be the first one that hits. Okay? So, if we go to the next day, you're going to see what we all call halo eruptions. Okay? Now, I mentioned this earlier, that when you're looking at this is an actual disc. So, we can't see behind it. Right? From this perspective. So, really what would be ideal is to have a side view also, which we used to have when we had stereo A. And that would be, let me do this. Stereo A used to be out here. Okay? We're here. It used to be 90 degrees even further. It gave us a partial backside view of the sun. But now it's hanging out over here because it's outlived its lifespan. I don't think they're going to send it back out at this point. I hope that they send something else out there. I'm not sure what the plans are with that, but it would be great to have some sort of, you know, view from the side. But we make do with what we got, and we're able to get, you know, pretty decent in what we're talking about. You know what I mean? So if we go to the second here, again, you got your halo CMEs. Now look here, guys. You see that? That's the kind of stuff I'm talking about with anomalies. That could either be a charged particle, or it could be light bouncing around inside a imager that takes the shape of a tube. Okay? These are not a Canon that you're holding in your hand snapping pictures. Or a Sanyo or a Seiko or whatever brand you want to say. Panasonic, Polaroid. Shake it like a Polaroid picture. Anyway, that's what SDO was doing, right? Ain't that what this thing was doing? What, it's shaking? Here, we'll shake it. Let's shake it. Come on, shake it. Yeah, shake it. Shake it like a Polaroid picture. Anyway, sorry. Sorry. But, yeah. I'm sorry, guys. Oh, Lord help me. Wow. I'm hurt, man. Hurt. Okay, anyway, you can see that. Now, if I go to the next image, it's probably going to be gone. Oh, imagine that. It didn't travel, right? It didn't travel, and we're not seeing it here. So if that was a real thing and it was traveling that way, we would still see it. So, just saying. And we're not. So it's a camera anomaly, guys. And that's, you know, it's kind of what I'll say. And let me say this also. it is a very legitimate question to wonder what the heck that is, okay? And I know I'm kind of making light of this, but sometimes we'll look at these and they'll be all over the place, right? The whole screen will be filled with them. That's just because the imager's having problems processing the data. That's what that is, okay? It can't get a correct image because of what's going on, either with the light, with maybe it's just getting hit with charged particles. That happens. But these tube style anomalies aren't like typically a what I would call a charged particle flying through in front of the camera or hitting the camera even. Those tend to be like just like really thin streaks going everywhere. Okay, this is more of a tube. You can see how it's kind of faded and fuzzy in the middle too, right? So that would lend itself to taking a tube-like shape. So let me just zoom in here so you guys can see that a little bit better. See? It's even rounded on the front. Okay? So that's just what I'll say. Now, there is a possibility that that could be some sort of a small meteorite or something like that that's hanging close to the satellite. And that's something else that people don't take in consideration. We have to understand where this satellite's at. Right? This thing, you know, it's 93 million miles from us to the sun. From the satellite to the sun, this satellite, it's 2 million miles. There's a lot of distance there, and we have no idea how far this thing is away from us. So we don't, with that being said, that means we have no idea of how big that actually would be if it was an object. If it's closer to the camera, that would be very, very small. If it's out next to the sun, that would be very, very big. Okay? It would be as big as that, almost. That's Mercury. Okay, so we don't have that data to look at and be able to confidently give any kind of intelligent, you know, positioning of whatever we're looking at. We have to have that distance to be able to calculate that. You know, and there's other ways to find size of things and all that with trigonometry and all that stuff. I don't have that kind of knowledge, so I always tell people, guys, go over and check out Tamitha Skov, Dr. Tamitha Skov. She's in my mind probably the leading space weather person on the internet. You know, it's free college if you go over there, guys. She'll do 4-hour live streams and teach people things. She's a professor at let's see here, Millersville University. She's a professor there. She's been on the Weather Channel. I mean, she's been all over TV. She knows what she's doing, and she explains things in a way, you know, kind of like Forrest Gump, right? In a way that I can understand them. Mama always explains things how I can understand them. Anyway. And believe me, sometimes I need to be treated like that. So, check her channel out, please. I would imagine, I haven't looked, I haven't got a notification, but she's probably going to do a show. I would imagine she'll be giving an update. Anyway, so we got Soho here again, and I wanted to make sure I, you know, made you guys have a little bit of an understanding of what we're looking at and where we're looking from. Because it helps us understand how powerful things are going to be, especially in the sense of how fast things are moving. Okay? Because what that will do, if we got a good gauge on how fast it is, obviously then we got a good idea when it's going to get here. Because we know where it generated from. It generated from the sun. That's 93 million miles away. So if we have a speed on something that's moving at a consistent speed, or something that's moving at a whatever speed, then we're going to have a really good idea when it's going to get here. And so with that being said, that is a halo CME. And then there was another one, partial halo right there. Then another one. Look at that. That's the one that was going off the north. Okay. We're going to go look again a little bit more in detail here in just a second. Of where that particular one was. Now this is our magnetosphere. Our magnetosphere is created. It's there because we have a magnetic field, and when we get hit by space weather, this is the reaction between our magnetic field and stuff coming from the sun. Okay? Sun's off to the left. What you're looking at here is just speed. Now, I'm going to say something here that I want everybody to really understand, okay? If you look at this, our bow shock is the first point of contact. You know what? As a matter of fact, I'm going to take you to a different model to explain that to you. But let's look at this first before we get moving. But this is density. The white is low density. The darker blues are the higher dense particles. Okay, so you can definitely see these things coming in and out. I haven't seen a magnetosphere model look like this in quite some time. And I'll explain more here in just a second. It's not nothing to be worried about. It's just something I haven't seen in a while. But you can see how when we start getting hit, right? So everything's just kind of hanging out right there. And then look, wham. And this is what's going on currently. This is the most up-to-date data of this. Timestamp 3:01 UTC. That means 11 o'clock. Or close to it, anyway. Eastern. Okay? But this is magnetic pressure. All this is showing you is the pressure it's putting on our planet magnetically. And when I say pressure, I'm talking about the magnetic fields. Okay? So we have this bow shock, right? So when we get hit, there's bunches of magnetic fields in between us and our bow shock. Okay? So when we get hit with space weather, it starts to compress those. That's where that pressure comes from. Okay? And so what happens is we get what we call compression and then rapid expansion. We'll win that battle for a few more minutes and our bow shock will shoot straight out off of this model. Okay? That's what happens. But this is pressure, and it's been a while. Again, like I said, I showed you guys an image like this, I don't know, a few weeks ago. I seen this. We don't oftentimes see it look like this in solar maximum. It happens. It's going to happen during solar maximum, but it doesn't happen often, is what I'm saying. And what I mean by that is there is no magnetic pressure at all. Anywhere. Okay, now I'm going to give you a little bit of a reason here too. Our bow shock, okay, first point of contact is off the edge here. So that means right now our magnetic field, the first point of contact is out here, right? So we're actually sitting back deeper in our magnetotail. So that actually puts you in a safer spot as far as how much you're getting hit with, okay? There's more protection between us and the CME is what I'm saying. And there's not as much compression. But when that compression happens, right? So if I take this down here, I'll be interested to see what it looks like right here. Okay, so here we go. See? The density started to hit. What happened? It compressed them magnetic fields, and now we got magnetic pressure. Okay? That's what's happening there. And you can see how we're deflecting it too. This is showing it really, really well. This is awesome. I'm not being able to show you guys this to this detailed. Okay, so it goes boom, it hits, and it gets compressed. Now watch what happens here on the edges. You're going to literally see our magnetic field deflect. Okay, so here we go. See it break off? That's deflecting. And we're now going to rapid expansion. We're shooting forward, right? So this is what happened. Compression. We're deflecting it. Now we're winning. Rapid expansion. Okay? That's how it works. So I hope I explained that well enough. If I did, let me know in there, would you? I need some feedback on that if you guys could. If I confused anybody on that, I apologize. I'm trying to do it the best I can in the most time efficient way so I don't waste your guys' time. But yeah. Oh, by the way, guys, Axe is going live here too. He's probably live right now. He's probably going at 11 o'clock, I would think. But yeah. Go over and check out Axe and Nacho, guys. You guys want to have a good smile and a good fun? I mean, it's great up there. It's awesome. Just go check out his channel. He's in my subscription list. I think he's on my awesome channel list too. But as you can see here, guys, this is the velocity again. Okay. Now, also, Marfugal is going to be going live here too shortly, I would think. Haven't got a notification from him yet, but it's coming, I'm sure. There's a lot of stuff going on in our world right now, and I highly suggest anybody that doesn't know who Marfugal is, Adam Marfugal and Dex, Marfugal TV, please go check out their channel tonight. There's a lot going on in our world right now, and they do a full bibliography of everything they report on. So they're fact-checking themselves. They're giving you guys the access to where they got their info from. So there is no spinning anything there. It's all there for you to look at. And it's so high in integrity, in my opinion. It's just great. Great stuff. They do a great job. So if you don't know who they are, please go over and check them out. You know, get in the chat and say, hey, Wages World sent me. Let them know you're there. It's the same family here as it is over there. Okay? Genius Footbirth! Heck yeah, baby. Love it. Thank you. Hey, Kristen, good to see you. Aaron's in the hizzy. Let me, guys, whoever got the gifted memberships from Genius and Planet Hermit, please tell them thank you. By the way, guys, I talked to my dad today. He wanted me to tell you guys thank you, okay, for praying for him when he swallowed that bee. Yeah, he was in the hospital for a minute, and he's better now, so, but he really appreciates it. So, anyway, just want to let you guys know that. Okay, so give me a roll call in there, guys, would you please? Please, please, please. If you would. Just general. Just kind of like your general area. Okay? Let's do this. Let's do this. Okay. So, again, guys, this is our polarized magnetogram. And colorized, I should say. But it shows us different magnetic positioning here. So you got your negative and positive. Now remember, they're going to be reversed in the north and the south. But I find it interesting that I was just talking yesterday about how the majority of our sunspots were in the south. And now we're starting to see some in the north again. So, you know, this thing, it just does. The sun does what it wants, when it wants, and how it wants to do it. Alright, so where we got people from? Ronnie K, Michigan, Northwest Ohio, Karen Myers, Shastina, Northern California, Kathy B. What is crack-a-lackin'? Phase of the Moon. What's up, Miss V? She's Taco Washington, baby. Oh, yeah. Wharton Thistle's in the house. See here, thank you. Okay, let's go down. I'm going up too far. KCMO. I'm not sure what that is. Kansas City, Missouri. Okay, I'm with you now. Sweet, sweet, sweet. Hey, miss, good to see you. I'm not sure what link that is. But, oh, Marfugal News. Thank you. Thank you for putting that in there. Appreciate that, miss. Hey, Trish, good to see you. Anna B, Pierre, South Dakota, Texas, baby. That's right, Joe. Hey, Joe, good to see you, Mr. Birdwell. Hope you're doing well, man. I pray for you a lot, brother. I really do. I'd like to talk to you again if you want to hit me up, man. Tiffany Stitt, Ohio. Ohio. That's right. Let's go back to the 70s, man. Late 60s and start singing that song. No, let's not, because that song was talking about a bad time in our country. Anyway, Char D, what's up? May Edwards, West Virginia, baby. I'm in La La Land. Hey, where's your sloth emoji at? You know, you can't say nothing without putting that emoji there. You know that, right? Mary Bryant, what's up? All right, guys. So, I haven't seen K+4 in here yet. Okay, no mandates, not a fit. What a name. What a name. That is awesome. Chattanooga, baby. Guys, if you've never been to a place called Ruby Falls, you need to get there. It is an awesome underground waterfall. It's in a mountain. And you can take a tour down there. If you're overweight like myself, you might want to go on a diet before you go down there. Because they will. They'll take you down on an elevator and you have to like really scoot through to get to where the falls actually are. But it's beautiful, man. It really is. If you've never been there, you need to go there. They got Lookout Point there too, where I think you can see 4 states from one spot. I think it's Tennessee, Georgia, I think South Carolina, and is it Mississippi or Alabama? I can't remember my geography right now. But anyway, you can see four different states from the same place. It's pretty cool. All right, so over here, now there's something else too, guys. Aurora. What are we looking at for Aurora? Well, let's go see where Aurora is at. How about that? Let's go check out the Aurora hub here. Oh, Lord. Look at that. That's tomorrow night. So anybody that wants to get Aurora photography, you need to get out there, okay? I would even say you could probably go out tonight and look, depending on where you're at in the world. So Eastern Washington, mist. Heck yeah. Heck yeah. I know, Mr. J. Poss, you're awesome, brother. All right, so, hey, Diane, good to see you. Okay, so, let's, hey, guys, by the way, on the members only stuff, I got some stuff put together already, so we're going to do that tomorrow, probably, I don't know, tomorrow evening sometime. Maybe even in the afternoon, but I'm going to try to do a couple. And again, guys, I asked everybody what time was good for them, and I'm getting answers all over the place. So I'm going to have to just pick a time and go there, and we'll see how that works. And if I have to do 2 members only streams, I will. I'll try to hit 2 different time zones here. But we're going to have some fun looking at some Zoom court, just so you know. I was laughing at some of this, I mean, just hysterical stuff. I mean, there was this guy that was getting charged with a suspended license, driving with a suspended license. He shows up to court, get this, guys, in his car driving. And the judge called him out on it and says, hey, weren't you just driving? What are you... And that's before the case even got started. He just started the case, and the judge told him he needed to park. Then the judge looked at the information, and this dude, he drove to the doctor's office, got into a Zoom meeting for his court date, and he was driving. he was getting prosecuted for a suspended license. So his bond, the judge revoked his bond and told him to report to jail within like 6 hours. I was cracking up. It was crazy. That particular clip kind of went viral, I think. Okay, so back to the Aurora. Sorry, guys, I got a little squirrely there. This is what we got going on right now. Nothing. This is something that, you know, when we're down like this, and we're not really having a whole lot of geomagnetism, and remember, guys, that's what causes Aurora. It's charged particles interacting with oxygen and nitrogen molecules and other molecules also. But the green comes from oxygen, and then the red Aurora typically comes from nitrogen. So, yeah, that's what we're looking at. So when we look at Aurora, it's a really good indication whether or not we're getting geomagnetic storm. Okay? Now, typically with these bigger storms, and what we're going to do now is I'm going to take you here and show you. Okay? Look what we got. G1, G2, G3, G1, G1, G2, G3. I mean, they got this thing bouncing around between G1 and G3 and G2, G3 for an extended period of time here. Okay? Now, we've under forecasted these things the last 7 or 8 times. Just saying. So, in my opinion, I think we got a chance, a decent chance, of getting past this G3. I think we got a chance to go into G4 again. That's just my opinion, right? You know, everybody has one, right? Anyway, but with that being said, I want you guys to really understand that. Now, we're already in October 3rd. We just flipped over. So here in about 24 hours, we should start seeing the beginnings of this geomagnetic storm. Okay, and it's going to be 2 or 3 separate ones here, but they might end up just blending together. They oftentimes do. Okay, now remember, this is a forecast, and they give themselves plus or minus 7 hours. So things could start earlier or later, and it could still hit their forecast. Now, if it's moving faster than what they thought, obviously it's going to get here sooner, which will do what? You guys know, right? It will make it more powerful. Okay? So, with that being said, I want you guys to understand that this BZ is going to be critical. Okay? This red line, we're looking for -6 on this data point. It is the magnetic positioning. Okay? So when we're in a negative position here with our magnetic field, we couple with the magnetic fields inside the CMEs. And it draws it in. Now, if we're in the positive, it actually deflects it. Okay? So this is a very critical data point. I've seen us get hit a lot harder than this, and us be in the positive and not even get to geomagnetic storm 1. Not even that high. So, yeah. Alright. So, that's pretty much it, guys. I'm going to go ahead and end up now. I think Marf's getting ready to go on. So, if you guys could, head over to Marfugal. Can somebody drop that link in there for me if you would? But I'm going to come on with some updates later on, guys. You got this comet that we've talked about already multiple times. Dr. Tony Phillips over here at spaceweather.com has got this circled. But if you guys have never been over to Marfugal, please go. Hey, Daryl, what's up? Kathleen, what's happening? It's your 30... Hey, my birthday, 30 days away. All right, cool. Happy early birthday. Guys, if you've never been to Marfugal, go over there and start typing in that chat. Say, hey, Wages World sent me. Let's get some chat messages going on over there. Get his video sent out, all right? And it's the same family over there, okay? But we will come back with more updates when things happen. And I'll be back with an update anyway. Look for a members-only stream tomorrow. If I get a wild hair up my booty, I might go ahead and do one tonight after Marfugal. I'm not sure yet. Yesterday, I'm sorry if you guys misunderstood what I meant with the poll. I apologize for that. I told you guys yesterday I'm fighting cellulitis, and I am sick, so I get exhausted really, really quick, and when it hits me, I have to lay down for a few minutes. And last night that happened right here at my desk when I'm doing this show. After the show, I was sitting here, trying to shut things down, and I woke up 3 hours later with my head on the desk. Not kidding. I think it happened when I was trying to watch Marfugal. I was trying to shut everything down. I was watching Marfugal, and my head just hit boof. I mean, I was out. So, anyway. So, look for that, guys. Okay, guys? We will see you then. Definitely tomorrow at least. And I'll do members only tomorrow also. So, just know that. Anybody's a member, click that bell. If you're not a member, click that bell. Alright? And I'll see you guys over in Marfugal, okay, guys? God bless. Yahusha saves. And as always, you can drink this Kool-Aid.